For double angle and half angle formulas, we will be solving problem 1 and 2. For the first problem, we have cosine to the fourth of theta minus sine to the fourth of theta has to be equal to cosine 2 theta. And problem 2 is sine of negative pi over 8. What we will do here is we will go ahead and write out the cosine to the fourth of theta and the sine to the fourth of theta as a square term. What I mean by this is we can also write the cosine to the fourth of theta as cosine squared theta squared. Here this looks very familiar to a formula that we've seen in algebra, and that's a squared minus b squared. These two are equivalent. This is equal to this. Here, this is our a term, and then this term is the b term. So it's a squared minus b squared. So if I substitute that into the right-hand side of the equation, then I end up with cosine squared theta squared minus sine squared theta squared. That's equal to the first term, which is cosine squared theta, plus the second term, which is a sine squared of theta. And I put that in parentheses. Okay, now which one of these looks familiar? Well, if you're familiar with the unit circle, this would probably strike you as familiar because this in reality is equal to 1. This cosine squared is really just cosine multiplied twice because that's what, again, exponents do, is you're multiplying this many times. So I have 2 with the square. And minus sine theta times sine theta. We can combine this expression into the cosine function. So cosine of the first angle, which is theta, and since this is a negative sign, we will use the opposite, so positive, of the second angle, beta. So alpha is theta, while beta is theta as well. So how many thetas do we have? You guessed it, 2 theta. So now we check. Does cosine 2 theta equal cosine 2 theta? And the answer is yes. So at this point, you know that the expression is equal on both sides of the equation. And this is a way of verifying that.